Hey, what's up, guys? In this video, I want to go through this Leetcode number 79, word search. So we are given a n by n grid of characters, and we call it a board. And also, we have a target word, and we need to return true if that word exists in the grid. So let's look at this example. Also, there's some restriction where we can look at the sequentially adjacent cell, and the adjacent is defined by a horizontally or vertically neighboring. So basically, we cannot go diagonal, we can go just horizontally or vertically. And also, this is very important restriction where the same letter cells cannot be used more than once. So that means if we are looking at a string, we cannot let go A, B, C and come back to B. That's not allowed. So let's look at an example. If we are given a target as A, B, C, C, E, D, so we can go like this. S, E, E, we can go like this way. And as long as we can find one word within a grid matching the target, and then we are done. In this case, A, B, C, B. So A, B, C, and then there's no B afterwards. So that's why it returns false. And we will solve this problem by using DFS. As you can see, this question was very popular, especially for Amazon and also for other big names. So let's run through the code in here. Let me squeeze to this end. Yep, good. As you can see, we first have, let me zoom in a little bit. We have a n row, so we are counting how many rows in the board, also counting how many columns in the board as well, and so directions. So we can move -1 and +1. We can move between rows, and then this one we can move between columns, and then exploring. So we keep track of what's the coordinate that we are exploring. So basically, for example, if the path looks like this, we keep track of what are the other points previously we already seen, so we cannot go back to that point that we have seen. So we have to move forward. So we cannot. So basically, this is exploring this set. That is to satisfy this constraint. The same letter cells may not be used more than once. That's why we need the exploring set. And before you go into this function, the DFS, and this for loop is how we traverse the entire matrix. So we looking through all the columns, looking through all the rows, and then we call DFS on it. So now let's look at the DFS. So if the pointer, so we are inputting the row coordinate, and so the starting row coordinate and the starting column coordinate, also the pointer. So the pointer basically pointing to the position of the word. So if the pointer is already equal to the length of the word, that means we are already finished the whole thing. That's why we can return a true. And then otherwise we can do the rest and proceed. So proceed. So we're basically checking the condition to see whether we can proceed. So if the row index is between 0 and the number of rows -1, because it's the index we're talking about, that's why we need the -1. Also do the same thing for column index. And if the coordinate has not been explored before, and also that character is equal to the word that is looking at that particular pointer. If all these conditions is satisfied, we can move forward. Otherwise, we return a false. So that means if this is fall off the edge, if the coordinate has been explored before. If the character is not matching our target, either one of these conditions is not met, we return a false. Otherwise, we can proceed. And how can we proceed? Is by adding it to the exploring, because we are exploring this coordinate right now, and we do not want the subsequent coordinate to come back to it again. Again, that's due to this condition. The same letter may not be used more than once. And then we are exploring other directions. So basically, we are calling different directions. As long as there is one is returning true, you can break the whole thing by returning true. So this can save a lot of runtime. And yeah, because as long as one of them is true, we can return true. And if none of them is true, we can move to this statement where you will remove it from the exploring path, so that that point can be explored again in the future, right? Because, for example, a path looks like this, but it's a dead end, but the path looks like this. So if a path looks like this, which works later on, and that point can become back to it, right? That's why we don't have to remove from the exploring. So let me repeat again. Let me explain myself again. So let's lay a path like this, and this is a dead end. You can see all the points will be in the exploring set, like this. And then we try a different path. After we remove this point from the exploring path, we can come back to it later on, right? So that's why we need to remove it. And if this statement returns, so none of the directions works out, and then we'll return the false for that particular exploration. And then we do that for each of the points, right? So that's why we call a DFS. As long as we hit find one word, we can break the whole thing by return a true. So let's run it, and it runs successfully. So this runs successfully, the whole thing, for all the test cases. Now, so let's analyze the time complexity and space complexity. For time complexity, it is big O of n times 3 to the power of L. So n is equal to the number of points in the matrix. So basically it's m times n, and 3 to the power of L. And that is because, let me read it for you. So for the backtracking, so this is our backtracking function, the DFS. Initially, we could have at most 4 directions to explore. So basically, it's all these directions that we talked about. All these directions. But the reason why we reduced to 3, because we won't go back to where we come from. As a result, and the execution trace after the first step will be visualized as a 3 tries a tree, and each of the branches represent the potential exploration in the corresponding direction. And therefore, in the worst case, the total number of invocation will be the number of nodes in the trinary tree, which is about 3 to the power of L. So basically, what it's saying is this big O of n, that n comes from this for loop, and within this for loop, we're calling the DFS, and that DFS is consuming 3 to the power of L, and that comes from this function, this for loop over here. Because we don't come back, that's why we only try 3 times. Because let's say we go up to the left or to the right, so the remaining direction that we have to come back, and we don't do that because there's this set is prohibiting doing that, and we need to do that for each of the character in the word. That's why it's 3 to the power of L. So for example, the first character has to do 3 times, second character has to do 3 times as well, and the third character has to do 3 times. So we can see that it's 3 to the power of 3 in that case. So it's 3 to the power of L in general. And for space complexity, as you can see, the main consumption of the memory lies in the recursion call of the backtracking function. The maximum length of the call stack would be the length of the word, and therefore the space complexity of algorithm is big overall. Yeah, so that comes from we recursively calling this a DFS function, and the worst case will be all the intermediate DFS call will be stuck in the stack, and that will consume some memory. And also in our case, we also need to have an exploring set, and that consumes some memory as well. But the official solution do not have that, and I put it here is a bit easier to understand. Yeah, so that's so much for this Leetcode problem 79 word search. I hope you like it. If you do, please like this video and subscribe to the channel. Thank you. Hopefully I will see you next video. Thank you. Bye bye.